Permutations and combinations can be used in various real-world situations. A common example is where you have 10 students and you want to pick a president, a vice president, and a treasurer. Well, there are 10 students that can be chosen for president, and 9 students left, because the same person can't be both, to be vice president, and 8 left to be treasurer, which is 720. But that could be written also as 10p3. So that's an example of permutations, because the order I pick the people, if the first person I pick is going to be president, it makes a difference in the order that I pick them. On the other hand, if you see the word committee is sort of the quintessential example of a combination question, because if I pick 3 students, regardless of the order, it's going to be the same committee. They don't have like roles the way like president, vice president, treasurer have, and that's why it's 10C3 for that one, which is actually only 120. So those 2 questions, one's permutations and one was combinations. In this question we have 9 people, 5 boys, 4 girls. We want to know how many 4-person committees have 2 boys and 2 girls. This is actually 3 questions in one. You work out how many 2-person committees, how many 2-boy committees I could make, and you work out how many 2-girl committees I could make, and you multiply those 2 things together. I'll explain why that is in a second, but it becomes 60. The reason why you multiply those together is if my boys I'm going to call A, B, C, D, E, and the girls I'll call 1, 2, 3, 4. So the 6, the 4C2 equals 6 is because 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. That's 1, 2, 3, 4, 5, 6 ways of picking 2 girls. And the boys, I can get A, B, A, C, A, D, A, E, B, C, B, D, B, E, C, D, C, E, D, E. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways. That's 5C2. But I can have AB12 or AB13 or AB14, so I can put each boy together with any of the 6, each pair of boys together with any of the pairs of girls. Same thing over here. And in doing so, I would get 60 things. So that's sometimes called boy-girl questions. If I want to rearrange the letters of the word math, I can put any of the 4 letters in the first place, any of the 3 letters that remain in the second place, any of the 2 letters that remain in the third place, and the last letter goes there, which is 24, otherwise known as 4P4, whoops, or just 4 factorial. But if I have repeated letters, it's not going to be 5 factorial, because these 2 A's count as the same thing. So I'll have, let's say I make this A red and this A green. If I switch around the 2 A's, it's still the same word. So we have to divide by 2 because 5 factorial 120 is too big to get just 60. So I divide by 2. There are 2 letters that repeat, or there's a repeat. 2 of the letters are the same, so I have to divide by 2. But if there are 3 letters the same, A, it's not going to be 6 factorial over 3, but it's going to be 6 factorial over 6, because this 2 was really a 2 factorial and 3 is actually 3 factorial. See, I can take these 3 A's and rearrange them for any, like this word, M-A-A-A-T-H. M-A-A-A-T-H can be written 6 different ways depending on how the order of these A's go. So you have to divide by 3 factorial to get that answer. End up, I think, with, is it 20? It's 6 times 5 times 4 times 3 factorial over 3 factorial, they cancel. That's 30. It's 120. If the word has multiple repeated letters, like M, A, T, T, H, we count the number of letters, 1, 2, 3, 4, 5, 6, 7, and we divide by, if there are 3 A's, you go 3 factorial, and there's also 2 T's, stick a 2 factorial there also. Ends up with 420. And with that, we get the famous Mississippi problem. There are 11 letters in Mississippi, but there are 1, 2, 3, 4 I's, there are 1, 2, 3, 4 S's, and there are 2 P's. So they all go down there. And we get 34,650. This topic is called distinguishable permutations, where you might have repeated things, so one permutation, but it's not a permutation or a combination, it's kind of like a mixture. There is a situation, like if I have 4 A's, 3 B's, the distinguishable permutations there are 7 factorial, there are 4 A's and 3 B's, but that's the same thing as 7C4 or 7C3. When it's like this with only 2 different letters, it can be thought of as a combination because there are basically 7 positions, and 4 of them, I'm going to pick 4 of them to become A's. And the order doesn't matter. By that I mean here's something like that. 1, 2, 3, 4, 5. If this is positions 1, 3, 4, and 6 that I'm picking to become the A's, it doesn't matter whether I say 1, 3, 4, 6 or 3, 1, 4, 6 or 6, 3, 4, 1. So it doesn't matter. You wouldn't know which I picked first. So it's 7C4 or 7C3 because I could also have picked which position the B's went in. If I have like a grid like this, and I want to get from here to here, and I'm inside this box here, and I could sort of jump either to this box or down, and I want to get from the start to finish, and I'm only going to go right and down. I could go like right, down, or I could go down, right, right, and there's going to be a bunch of paths to getting there. But if I write out the paths, right, down, or here, down, right, each path will be expressed as a 5-letter sort of word that has 3 R's and 2 D's. So it's going to be 5C2, or 5C3, or if you like, 5 factorial over 3 factorial, 2 factorial, but you're looking at it as a Mississippi problem. No matter how you choose to do it, there are 10 paths. Here I have 6 points on the circumference of a circle, and I joined them together. Any 2 points got joined together. If I want to know how many chords there are in this circle connecting 2 points on the circumference, I can get that by doing 6C2, which is 30. Which is 6C2 is 6 times 5 over 2, which is 15. That's how many line segments there are. Because I can pick any 2 of them and join them, and the order doesn't matter because if I pick BF or FB, it's the same line segment. I could also get what's called a cyclic triangle or cyclic. Here's like triangle like this. The number of cyclic triangles is 6C3, which is 6 times 5 times 4 over 3 factorial, which is 20. Because I'm picking 3 vertices, and the order doesn't matter because whether I pick ACT or DAC or DCA, I get the same answer. And those are various applications of mostly combinations.